ITS Statistik Department, which is located in Surabaya. Institut Teknologi 10 November, or known as ITS. It was first established in 1978, which at the time was one of the areas of specialization in the mathematics department of the Faculty of Exact and Natural Sciences. Was first established along with ITS Statistic Department, which is located in Surabaya of Statistics, Institut Teknologi 10 November, or known as ITS. It was first established in 1978, which at the time is one of the areas of specialization in the mathematics department of the Faculty. ITS Statistik Department, which is located in Surabaya. Institut Teknologi 10 November, or known as ITS. It was first established in 1978, which at the time was one of the areas of specialization in the mathematics department of the Faculty of Exact and Natural Sciences. Along with the changing time in 2020, it officially changed to the Department of Statistics, Faculty of Science and Data Analytics.
Departemen Statistika saat ini telah mempunyai 3 program studi. Program studi S1 Statistika, program studi S2 Statistika, dan program studi S3 Ilmu Statistik. Ketiga program studi tersebut semuanya telah terakreditasi A. Sejak tahun 2019, Departemen Statistika telah mempunyai program kelas internasional bagi program studi S1. Kelas ini disebut IUP atau International Undergraduate Program. Pada kelas internasional, mahasiswa akan diberikan keahlian dan pengetahuan statistika di berbagai bidang dalam kelas dengan pengantar bahasa Inggris dan fasilitas yang lengkap.
From year to year, Statistics Department graduates have worked in various fields. In the development of industry and technology, we have established cooperative relationships with the universities at home and abroad, as well as government agencies and private companies that have been established and will continue to be improved. as means of supporting our needs. Until now, we have 5 laboratories including that Laboratory Computational Statistics and Data Science, Laboratory Business and Industrial Statistics, Laboratory Social Statistics and Population Studies, Laboratory Health and Environmental Statistics, Laboratory Economics and Financial Data Analytics. We have other supporting facilities as below. It has classroom, reading room, trial room, toilets, gazebo, Sigma Garden, basketball court, as well as public facilities such as malls and ITS Central Library.
Dan di statistika ITS kita juga belajar tentang komputasi. Dan banyak banget hal yang bisa kalian pelajari di statistika di luar dari hitungan. Dan implementasinya di kehidupanku, aku jadi tahu gimana caranya mengolah data yang baik dan benar. Dan ini berguna banget di kehidupan sehari-hari untuk membantu kita mengambil sebuah keputusan.
Di Departemen Statistika terdapat akademik dan non-akademik. Di akademik sendiri, aku mempelajari tentang pengantar metode statistika, analisis numerik, dan desain eksperimen. Sedangkan non-akademik, aku tergabung dalam staf himpunan statistika dan staf UKM Pramuka.
Kami berkomitmen menjadi lembaga pendidikan dan pengembangan statistika bertaraf internasional yang berkontribusi dalam ilmu pengetahuan dan teknologi, khususnya bidang komputasi dan sains data, ekonomi dan finansial, sosial dan kependudukan, lingkungan dan kesehatan, serta industri dan bisnis.
Bismillahirrahmanirrahim. Dear the speaker of today's international seminar, Dr. Alphonsus Julanto Endarta, good morning. We are very honored to have you today. Dear all the Academia of Department of Statistics, Institut Teknologi 10 November, especially the head of department, Dr. Kartika Fitriasari, the head of postgraduate study program, Dr. Dedi Dwi Prastyo, all the committees, all the lecturers, and the participants of the seminar. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Alhamdulillah, all praises to Allah. Apart from any circumstances that we are facing today, we are happy, healthy, and ready to participate at the international seminar entitled Applied Statistics in Industry and Transportation. This seminar is organized by the Department of Statistics, Institut Teknologi 10 November, in collaboration with Nemosis, a consultant company based in South Korea. My name is Nofri Suhermi. I am a lecturer at Department of Statistics, Institut Teknologi 10 November. Today, I will be the moderator for this seminar. And the rundown for this seminar consists of first, opening from the moderator, the second, opening speech from the representative of Department of Statistics, the third, photo session, and afterwards we will have the main session of the seminar, which is the keynote speech from the speaker, and then followed by discussion session, and at the end, it's the closing for the seminar. So without further ado, we will start the session by opening speech from Department of Statistics, at the moment represented by Dr. Dedi Dwi Prasetyo as the head of postgraduate study program. So please welcome Dr. Dedi Dwi Prasetyo. Time is yours.
Okay, thank you, Pak Nofri. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. It's so wonderful to see you all here in this sunny day. At least in my place, it's sunny. To the lecturer, to the student of ITS and from other university, and all participants from many institutions. It is a great pleasure for Department of Statistics ITS to welcome you to this international online seminar. We would like to extend a special welcome to the Speaker of Honor, Alfonsus Julanto Endarta, PhD, who will be speaking after this. We are so excited to have you all here to participate in our international online seminar organized by our Department of Statistics, Faculty of Science and Data Analytics, Institut Teknologi 10 November. We couldn't have pulled off this online seminar without the hard work and the dedication of the committee. I call Ibu Kartika, Ibu Adatul, Ibu Wiwawati, Pak Hasan, and also the host, Pak Nofri, who prepared this event very well to make today a reality. We also tribute this seminar today to almarhum Dr. Suhartono, who are very close to our speaker, Alfonsus PhD. Aside from this seminar today, we, Department of Statistics ITS, frequently held the online webinar or seminar. So please visit our YouTube channel to get updated. Okay, then, as mentioned by the host, that I was mandated on behalf of the Department of Statistics to open this online seminar. So on behalf of Department of Statistics ITS, by saying Bismillahirrahmanirrahim, I open this international online seminar. I do hope that today inspires idea and discussion around the ways that we can make our science and technology be better and better. Okay, thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Dedi, for the great opening. So now it is time for photo session. So for all the participants, you can open your camera. So we will take photos. Maybe the Bu Adatul will take over this session, maybe. So there is a we already send the background for your photo, so we could you could apply the virtual background, then we could take the photos. So please, for all participants, open the camera and then we will take the photo first.
Okay, Rita, in slide 1, maybe. Next, slide 2. Next. Okay. Photo session.
Okay, is it done? Oh, yes.
Yes, it's done.
Okay, thank you, Bu Adatul. So, so now we go to the main session of the seminar, which is the keynote speech from Dr. Alphonsus Julanto Endarta. Before we start the talk, I will read his curriculum vitae first. So, Dr. Alphonsus, he obtained his bachelor degree in statistics from Institut Teknologi 10 November in 2009. And then he obtained his master degree in statistics from also Institut Teknologi 10 November in 2011. And then he obtained his PhD degree in industrial engineering from Pusan National University, South Korea in 2016. His working experience, he's been a researcher at Department of Industrial Engineering, Pusan National University, and also he's been a research professor at Department of Industrial and Management Engineering, PostTech, also in South Korea. And he is currently working as a principal researcher at Nemosis, South Korea. He also has some awards. He obtained Outstanding Paper Award from Emerald Literati Awards 2018. The title of the paper is A Preventive Maintenance of Circular Consecutive K out of 9 F Systems. And then he also has published many papers in prestigious journals and conference, especially in the field of reliability and time series forecasting. And okay, so before we start the session, so to all participants, you may ask the question on the comment box, either on Zoom or YouTube. And you can definitely use English. Dan bagi Bapak Ibu juga dipersilakan untuk bertanya dalam bahasa Indonesia. And also you can write the question on the comment box. Also maybe you can ask directly after the presentation. So the title, okay. So and then the title of the talk is Introduction to Reliability, Availability, Maintainability, and Safety on Railway System. So let us welcome. Are you ready to give the presentation?
Yes.
So okay. So that you may start your session. So time is yours.
Thank you. First of all, I would like to say thank you for ITS and Department of Statistics for giving me the opportunity to share my knowledge, especially on reliability maps. So, yeah, so as the moderator said before, so I studied statistics in ITS for my bachelor degree and a master degree. And at the time, I focused on the time series forecasting. And for the doctoral degree, I came to Korea and change the topic, the research topic to the reliability area. And in 2016, I graduated from the doctoral degree. 2 years in the research work, laboratory, and the PostTech. So similar to ITS. Then in 2019, 2 years ago, I started to work in Nemosis. So Nemosis is the consulting company in ramps analysis, mostly the system. It's about railway systems, like the railway vehicles, the trains, electricity, and so on. So today's topic title is the railway ramps, and I just explained briefly about the introduction. So it's really basic ramps analysis with application in railway system. So Nemosis is the ramps consulting company. Yeah, most of the works are qualitative data analysis, like Fmea, and so on. So we work with train manufacturers or the railway system operating companies. So the quantitative data analysis, the optimization. So we also provide software solution or just a simple calculation software. Nemosis itself, it's established on 2016, so it's not a really big company, it's a really small. So we have now like 12 workers here, and the customers of our company mostly is the Hyundai Rotem. So Hyundai Rotem is the manufacturer of the trains, and Korail may be similar with PT KAI in Indonesia. So it's the main government train operating company, railway operating companies, and Seoul Metro and Incheon Airport Express. So most of them are the railway operating business. So today contents of this presentation is just simple. So I will introduce the railway ramps. So what is ramps, and how we analyze the ramps of the railway system. So in this part, I just make a reference to railway standard, international standards. So while in the manufacturing of the railway vehicles or the other systems, we have to refer to this standard. And then just the other three sections, just parts of the ramps analysis. So how to assess the risk, so how to and the reliability prediction and the efficiency. So as we know, in the real world, all products or systems and cars and humans are unreliable. So sometimes we will fail, we will broken. So know this knowledge, the reliability theory, how to improve the product reliability design, the design stage, and how to control into manufacturing, so we can have the best, optimal design, optimal product for the control, for example. How we design the optimal operation procedures and the maintenance procedures for the operational site. So yeah, so I guess for all people, it's the most common words we have heard is reliability. So yeah, it's the background.
Sorry to interrupt, Dr. Alphon. Could you please speak a bit louder, because or maybe you could put the mic closer to your mouth, because some participants said that the sound is not quite clear. So maybe, yeah. And also maybe for the participants, you can maybe increase the volume of your phone or your laptop so that you can hear the sound clearer. Thank you.
Okay. I think
Ih, nasi laptop teh.
so in the reliability area, so the data mostly are lifetime data, the supply file, failure time data. So the focus, the main objective of the RAMS analysis is how we want to prevent the failure occurrence, or how, if the failure occurs, we want to reduce the risk, reduce the criticality of the failures, the accidents, and so on. Because, you know, it cannot be avoided sometimes. So like the lights, like light bulb, it will break. Like, and when for example, this car accident, if the brake, we do not have good maintenance there, with the failure of the brake system, the car accident may occur. So in the RAMS analysis, we want, once again, how we improve the reliability, how we improve the availability, how we improve the maintainability, and how we want to improve the safety of the system. So RAMS, what is RAMS here? It's the RAMS, RAMS here, reliability, availability, maintainability, and safety. So reliability is the ability to perform the required without failure for a given time interval under given conditions. So we have the given conditions here. Availability is the ability of an item to be in a state to perform a required function under given conditions at a given instant of time, or if over a given time interval. Maintainability is the ability to be retained in or restored to a state to perform as required. And safety is the freedom from unacceptable risk. So here is the interesting word is unacceptable risk. So there always be a risk of the failures, of the accidents, but we have to define which level is acceptable, which level is unacceptable, because we cannot avoid the failures, we cannot avoid the accidents sometimes. So in the railway ramps, these are the standards we have to follow. And in this presentation, mostly I refer to the first standards here, the EN 50126. Number 1, it's the railway applications, the specification and demonstration of reliability, availability, maintainability, and safety. The part 1 is general RAMS process. So it's the basic RAMS process for the railway systems. And here you can read the other standards. So yeah, railway systems very large area. Like we have the trains, we have the communication systems, we have the many other systems, and thus the railway systems, there are the specific standards for the railway systems. Even though there are similars with the other systems, the RAMS analysis for the other systems. And here is we have two kinds of standards actually. This Senelec, which is the producers of the EN standards, the European standards, and the IEC. This is the international ones. Yeah, so this is like the history, the change, the flow of change of these standards. So it get updated to follow the change of the railway trends and so on. So in railway ramps, this is the elements, the main elements of railway ramps, and the relationship between these railway ramps elements is like this. So as before I said, the ramps are reliability, availability, maintainability, and safety. So there is safety and availability, and these groups is managed, is improved, is affected by reliability and maintainability. This is the how fast the system will fail, or how we should perform the maintenance, how fast the maintenance, and so on, and what is the definition of the operation and maintenance procedure. So how long it will be operated, so how long and how we do the maintenance. It's in the most common sense that safety, the most safest thing of in railway systems. For example, we want to avoid the train collisions between two trains. The most the safest thing is, well, don't use trains, right? Don't operate trains. So it's the safest thing, right? But the problem is, the safest one is the lowest availability. So it's like the inverse relationship, you may say. And thus, we want to find in which level we should operate the trains to obtain, to get an acceptable safety level and to meet the availability requirements. Yes, like this. And this is the explanation from the standards. So in availability, what affect availability here is reliability, maintainability, and operation maintenance from the previous graph. So in reliability, we want to first define what is the possible failure modes here. Failure modes here is like the failure types, like if you have the light in your room, it 100% you cannot turn on the lights. It's one of the failure mode, or it's blinking. So it's how we define the failure modes. And then the frequency of the failure, and then the consequence. So it affects the reliability, and in maintainability, it's like the frequency or the duration of the maintenance, both planned and unplanned, and how to detect the failures, and so on. And the operation and maintenance stage here, you can see here, it's the all possible operation modes and required maintenance task. Also considering the cost. So the human factors, because we have to consider the mechanics and so on, and the equipments for the maintenance and operations. And the safety related ones, it's like this, it's the failure modes which affects the safety, because sometimes even some components fail, it doesn't really significantly affect the safety. Even if it's failed, well, it doesn't matter. It doesn't affect the human health, it doesn't affect the environment. So it's not safety related failures. And similarly, like the frequency of the occurrence and so on. So these are the availability and safety factor RAMS elements. Yeah, so in the graph, this is the expansion in the graph illustrate. So these failure modes, some of them are safety related failure modes. That means that if these failure modes occur, it's emergency, it's important. So we have to reduce the focus of the RAMS analysis related to safety is we want to reduce the safety related failure modes and the risk and the consequences and so on. And here is the factors influencing RAMS. So I refer to the standard. Here we have like safety for parts for stage here: safety, mission reliability, availability, and life cycle cost, which all four are affected in the conditions, like the system conditions, operating, and the maintenance conditions. The system conditions is the failures which occurs because of the system, like the system design, which failures modes related to the system design in the system conditions. And the operating conditions is mostly the failures affected because of like the cause from operation phase, when the terrain like affecting by environment, human, the driver or the mechanics failures or so on, and also the maintenance, same here. So as a statisticians, maybe it's like the failure, systematic failure, and this random failure here. Maybe this random word here will be our can be our focus. So it's simple, like the simple definitions of random failures is failures occurs due to like certain causes which can be described by statistical distributions. So sorry. So random failures here can be operating modes, environment, stress degradation, wear out, overstress, etc. So before I explain more about the random failures, let's see the systematic failures here. So systematic failures is failures due to the errors in the system lifecycle activities, but especially we may say it's in the design stage. And mainly caused by human errors, because like we can see here is errors in requirements. So it's like when we want to design a new system, we manufacture a new system, we have to make the requirements. We have to define how long it can be used, how long it can be operated, and so on. So we have to design. So this systematic failure is like when we know how to make the systems, we know the design, but we make an error in the design. We make a mistake in the conclusion and so on. So it can be design inadequacies like the mistake and the manufacturing error and the software error, because these failures is actually avoidable. We know these failures can occur if we make these mistakes. So the systematic failure is usually listed, and we want to prevent these failures. So we have the documents and past experience and data, and we refer to those data and so on. So back to the random failures is then the failures which occurs not from this situation, not from the systematic failure situation. So, and this is really random. It can be in the environment, the external cause, which is not considered in the design stage. So if we see here, it's human errors are we can see human errors, human factors, human errors here. So many human related stuffs. So let's see here is what is human factors in the RAMs. So human factors are the core, is the main aspect here, because in this RAMs analysis, it's humans, it's persons, it's people who designed the system, who designed the requirements and so on. So human factors here are very important. And yes, human influence, it can be random and systematic failures. So when the failures, you can see here in the below, when the failures occurs in the operational and maintenance phase, it's usually in the random failures. And when it's failures in the early phase, which is usually a design stage, it's a systematic failure. So we have this main goal. Actually, it's like goal of the RAMs activities. So what we have to do in RAMs is we want to achieve the system performance, because we design the system, so we design the performance. This train should be working at all time. We want to have those goal, right? So we want the train will not be late, it will not be broken, but because some goals are actually doesn't make sense, because system will be sometimes broken. So we have to define what we wanted, the performance that we wanted, and the requirements. And by RAMs activities here, we want to achieve these RAMs requirements. So what is the RAMs requirements here? We showed in the parameters related to reliability, availability, maintainability, logistic support, and the safety requirements as the parameters. So for the statisticians, for the data scientists, data analyst, maybe these symbols, this parameter is like, oh, it's very refreshing. It's failure rate, mean uptime, and yeah, mean operating time to failure, mean operating time between failures, failures probability, and reliability, and so on. So I will not explain how we calculate these parameters here. And this example is usually used in the railway applications. And the maintainability parameters is the mean downtime, and the mean operating time between maintenance, and so on. So with these parameters, we define the requirements, like, for example, we want that the system can be maintained, can be restored to a working state in 1 hour. So like this, like such requirements in the RAMS requirements definition. This is the availability parameters. So there are many parameters here related to the RAMs. Even though we may choose, we can choose which ones to be considered in the system design. And when we define the system RAMs requirements, we discussed with the manufacturers, we discussed with the railway operators, because we want to like maximize, of course, we want to maximize the reliability, availability, maintainability. We want to minimize the cost. We want to get the safest system, right? So the numbers should be obtained by discussion with the manufacturers, the railway system operators. So in the RAMS analysis, this is the one approach. It's the risk-based approach, because the failures is unavoidable. We have to analyze the risk of the failures. That is how often it occurs, and when it occurs, what is the consequence, and then how we make the measures, how we can prevent or reduce the failures itself. So which is usually started in the design stage. Yes, so the below one is in red. The goal is to reduce the risk to an acceptable level. Reduce risk to the unacceptable level. So we have the acceptable level. So we have to define which level is can be accepted, and so on. And to improve safety, of course we designed the safe failure mode. So when the brake system fails, the train should stop. Like we have to define the functions and how to make the failure safe as possible. So this is the RAM's management process. Started from the development stage to the final stage in the decommissioning. Yeah, so you start from the concept, stage, system definition, and operational context. Risk analysis and evaluation, specification of system requirements, architecture and apportionment of system requirements, design and implementation, manufacture, integration, system validation, system acceptance, operation maintenance, performance monitoring, and the end is decommissioning. So this stage followed by each arrow, this means that we have to verify it. So we have to check when we make the system concept, is the concept makes sense in its logic, is okay. So we have to verify every stage. Is the risk analysis method is right? Because as the consultant, usually we don't have like the big knowledge about the system, like the mechanical things. So sometimes we have to verify these results, this process with the railway manufacturers and operators. So these verification and validation tasks are very important for every stages. And here you can see the tasks for each stage are related to the RAM and safety. So usually we divide into RAM into two parts, and RAM works, RAM task, and the safety task, because it's significantly different process. So in the RAM, we have to define the MTTF, the target, the system target, and so on. Yes. So in the second one, we have to make the RAM policy, RAM plan, also the safety policy or plan. We perform the risk analysis. In the safety task, we also establish the hazard log. We record all the possible hazard. And of course, because there is a verification task here, we should update the previous documents, like safety plans and safety analysis documents and so on. Yeah, so if we see here in the task, there are mostly the analysis are the qualitative data analysis, like risk analysis and risk assessment, and there's no explanation yet. Okay. Hazard analysis. So okay, Fmea is part of the design and implementation task here. So it depends on how we make the RAM plan. the models, the analysis model can be different. So based on the previous RAMS management process, this is just example of the analysis. So in the first concept and system definition stage, where we make the previous or the history data related to the systems, and we make the RAMS plan. And the risk analysis here, we may see the Fmea and preliminary hazard analysis, PHA, hazard log, and the design and implementation. We get the Fmea again, and the maintainability analysis. We predict the LCC, the life cycle cost. So it's related to the cost of the train. And this part is related to the safety. Is the HAZOP, SSHA, IHA. So there are many kinds of the hazard analysis. Also, we have the fault tree analysis and so on. Even though I cannot, because of the limited time, I will not explain all of the analysis. I will just show briefly about the Fmea and the hazard analysis and the risk assessment, which is a part of the hazard analysis. And yes, so this part is like it's similar, I think, for not only the railway systems, but for all other systems. So when we design the new system, new equipment, new products, started with concept and ended in the when we throw away, we refurbished or whatever is the final stage, including operation and maintenance stage. So operation maintenance stage is really a small part of the life cycle. Like this is really surprising, maybe, because when as a data analysis, as the data analyst or data scientist, as a statistician, we usually only focus on the failure time and how to estimate the failure distribution and the MTTF and so on. But actually, before we do those tasks, actually it starts from the concept design and so on. So let's see, here is the risk assessment. So the objective of the risk analysis is this, you can see here. We identify and classify the RAM and safety related hazards. And we want to select the risk acceptance principle, and we define and apply the risk acceptance criteria. We assess the risk and we establish the process for ongoing risk management. This ongoing risk management is very important because, as shown in the previous slides, the life cycle is very long, started from the design and ended in the final decommissioning. So it and related to the train systems, the train operating a lifetime usually 25 years or 30 years, around between those values. So the operating and maintenance life itself is very long. So to reduce the failures which can occur in those stage, we have to make the risk management, and we have to also always keep updating the risk, the possible failures. So in this risk analysis, first we have to identify the undesired events. So let's say the hazards, that is the undesired events, which can lead directly or indirectly to the losses during operation and maintenance of the train or the other railway systems. So, for example, here we want to these effects. So, the events which harm the passengers, the workers, or publics, or which harm the environment, so on. And we identify why these undesired events occur. Like, we have to identify the cause. So, for example, here, is it because the part, component, subsystem, or the system failures? Or is it because of the human errors? Or is it because of the operational conditions? Yeah, so many other causes there. And after that, we have to identify how we can make the measure, how we can control these hazards, these undesired events. So, for example, to prevent, to reduce the fire which can occur in the trains, we provide the fire extinguisher. Yeah, so that's the example. And then we estimate the frequency and the consequence. So usually this estimation, usually we don't have the data, so we have to make a logical conclusion, logical thinking, or we have like a discussion with manufacturers, with railway operating companies. And then we can also make an additional control measures to further reduce the risk, consequence, and so on. And we record, we also provide the document evidence. Is it applicable? Is it already applied in the system or not? So this is the relationships of the cause, hazard, and accidents. So we have the cause of hazard, and this because of these events, these undesired events, this hazard occur, and because of this hazard and other triggering events, environment or human errors, and so on, the accident happens. So there will be train collisions or train or component failures, and so on, fire, and so on. In the frequency, when we estimate the frequency, because usually we don't have the data, we don't predict the frequency. We only, we evaluate through the logical thinking and with the manufacturers' discussions. So we define this frequency level. It's just an example, so it can be make new, like it's just an example. We can make a different range from this one based on the discussion with the manufacturers and the railway operating companies. So the frequent, probable, occasional, rare, improbable, and highly improbable. So there are 6 levels here. And for example, in the 24 hours, how it can occur. This is sample, and this is based on the distance. For example, we have 3 levels, 3 categories like this. So more than once every 5,000 kilometer, or once every 25,000 kilometer, and so on. And this is related to the severity, like the consequence of the accident, or whether the failure will prevent the train movement, or it will make a delay, or it doesn't significantly affect the performance. So this is we may define the category. And this is another example for the severity of the accidents. So if we consider the environment and the human and the public, or if we consider the effects to the service and operation. So first, when we do the risk analysis, we have to define what levels we will be considered in the risk analysis. Then, based on those categories, we make the risk acceptance category. Because some failures are not significantly affect the environment or the operation so well, even though it fails, it is still acceptable. So we want to make those conclusions. So we have intolerable. So this intolerable risk should be eliminated. So we have to find out the measures how to eliminate this hazard. Undesirable, tolerable, negligible. So this is the example of the risk acceptance category. So we call it risk matrix here. So we have in the previous slides, we have this frequency level, and we have the severity level. So when it's okay to fail and highly improbable, then we may not make any other controls. So we may neglect, we may just let it happen and just correct after it fails. For example, and when usually this part, intolerable and undesirable, when we have these hazards with this level of risk, the red and yellow colors, we have to define, and we make the design. We have to update the designs to reduce this risk. So how we apply this risk matrix, we usually perform the hazard analysis. So for example, we have a preliminary hazard analysis and subsystem hazard analysis. So PHA is performed at early design phase. So we have the system requirements. We have defined the system objective and so on. So then we identify the possible hazards, the possible undesired events at system level. And the SSHA here is the hazard analysis, which is performed after we define the detailed design. Usually say we have arranged the product breakdown structure. We may consider the BOM, the bill of materials of the system. So we have like thousands of components should be considered here, and each component's hazard should be identified. So this case really it's really heavy works, because in one train they have like more than 10 large systems, like the lighting systems, like the propulsion system and so on. So each system have like hundreds of components. So one train can have around 3,000 components, parts. So, well, it's really great work. And then this is the PHA steps. So we have the system. We first identify the system and operation, and identify the operating modes of the system, and identify the hazard, the cause effects, and the relevant operating modes. And then, as explained in the risk analysis, we assess the frequency, severity, and we identify, design the control measures. And always we update we verify and validate with the manufacturers and the railway operating companies. Then from this PHA results, we have the hazards, right? We have these hazards in the early design stage, and we can use these hazards in the next level hazard analysis, this SSHA. So in the lower level parts, we do once again for all the components, we identify the hazards, failure modes and causes and consequence, and we evaluate the risk and so on. So also in the operating and support hazard analysis, this one related to the operation and maintenance part. So this scope is normal operation, testing, installation, maintenance, training, and so on. So in this part, what is the failure modes and how to prevent those failures and so on is analyzed here. Well, yes. So this is like the sample template for the hazard analysis. So for the SSHA, we just record what is the system, what is the subsystem, and when we do this analysis, like what is the hazard. So what is the hazard which may lead to accident, and what is the cause, what is the effect, and the risk, and what should be designed for the control measure. and after we apply these control measures, how it affect the risk. So whether the frequency will be lower or whether the severity will be lower, so like that. And the status here, whether this control measure or this hazard analysis is finalized or still updating. So it's like an ongoing risk management process. So this is like one of the qualitative data analysis here. So reliability prediction. Yes. So this reliability prediction, it's really different from what we learned in the class, in the reliability class. It's not about the calculation. It's not about the estimation model. Because of like the complex structure of the system, or because of the large numbers of the components. Usually we use the software to calculate this, and also because of the limited failure data of the thousands of components. Yes, we use the library from the software. And first, we define the system structure, the components, what the components composition, and we determine the reliability prediction model. We take the items in DBF, and then the system in DBF. And this part is what we know from the reliability class. And this is the example of the reliability prediction template, because, well, there are many templates, and there are many sheets for each RAMS analysis. So this is the reliability prediction model. So based on the field data. I'm sorry, this files I translated from the Korean version, so but I forgot to change from the Korean file. And based on the field data, the problem is when we don't have the data. So the field data must be obtained. So it's limitation here. And the library approach, we have like this software, so many software libraries for the reliability prediction. So this is the standards. The problem there is the difference is significantly large when we predict through the library data. And then there are accelerated live testing model. The problem here, well, there are so many components. There are so many when we use the system-based one, the system is actually really large, and each component's requirements are different. So it's really complex to use the accelerated live testing model for the railway systems usually. So yeah, so after we predict the item reliability, we predict the system reliability. Just we use the reliability block diagram or any other prediction model. And also can use the mathematical model if it's just a series structure and simulation for not series structure. And this is like the steps to the reliability predictions. So we have the part list, like thousands of parts, and also we can consider the drawings to see the system, the structure, and the information of the parts. Then we make a table to check the function analysis. And this is similar. So then we may have this the final table, and we use like this is the software, Relax software for reliability prediction. So we input this information in Relax software, and we also input those parts informations like the stress level and so on. So through the software, we may have the failure rate, predicted failure rate. So this is the another standards to calculate the reliability predictions. Okay. So the last one is I will explain shortly about Fmea, the failure mode effects and effect in criticality analysis. So first, Fmea, there are two, Fmea and Fmea. So Fmea is the failure mode and effects. So identify the potential, the possible failure modes, the causes and effects. And the criticality analysis here is also similar to the risk evaluation. So based on the severity and the frequency of the occurrence, we evaluate the risk or the criticality. And here item is the parts of the systems, and the system itself with the highest level of the BOM, of the product breakdown structure. And we have the function, that is the role of the item, what is the function of the item, and the failure mode, failure effects, severity, and criticality here. Similar with what I have showed in the risk assessment. So the goal of the Fmea is to reduce and eliminate the failure modes which could have catastrophic impact on product performance. So this is also one of the risk assessment model. And what we want from Fmea here is from the designed information, we want to make sure the risk is minimized and the cost is minimized, and also in the limited time and so on. So of course the goal is to improve the reliability of availability also. And based on the Fmea, we can propose how to one of the control measure is how to maintain, how to make the maintenance task. Can we may only change change the item with the new one, or just clean, or just lubricate with the oil, or what kind of maintenance task? Also here we can make the recommendations of the maintenance task. And related to the product safety, yes, we also want to prevent the failures in advance, and so on. This is actually really similar to the risk analysis, and this is the template of the Fmea for the item, for each item. The function, failure modes, it's really similar to the risk analysis, risk assessment, previous slides. And what kind of preventive or corrective actions is related to the maintenance task, which can be proposed to reduce the failure risk. So usually we are confused on how to define the failure mode. So the easiest one is the failure mode. We can see the failure, like for example, here it's cracked or sticking deformed or short circuit, loose or leaking, like this. And the failure effects, it's the effects on the operation or others, or the service, or the human health, or so on. And the cause of the failure, we can consider these questions to define the failure cause. This is the example, the material or part selection error, or the mistakes in the inadequate design of life estimation, so on. This is the example of the failure mechanism here, where fatigue, corrosion, degradation. So similar with the risk assessment, here the criticality part. When we define this column, the criticality, we may consider the frequency and the severity levels. So this is to review what we have learned in this webinar. So I've explained shortly, very briefly, about the FMEA, the hazard analysis, which is the preliminary hazard analysis, or SSHA, and OSHA, LCC, the reliability prediction, trend prediction. So actually, availability and maintainability prediction also can be done. So there are many other process, many other analysis model which can be performed during this RAMS analysis. Though due to the limited time, I just select like the most common analysis model here. So this is the end of my presentation.
Okay, thank you, Dr. Alphon. It's a very long presentation and very complete material. So now we will start the discussion session. So we already have some questions from the participants. I will read the first question. This is from Pak Krisandi Lande. You may also see the question in the Zoom. So and also I will read this. So the question is, in this explanation, RAMS apply to railway. Can it also with the same indicator also be applied in maritime transportation cases, for example, for ship operations? So that's the question. Or maybe you can
Yes.
open your mic. Yeah, please.
Yes. So can it be applied in the other sectors? Yes, of course, because what I have explained here is like the very basic process of the RAMS analysis. Maybe the difference is there should be a standard related on the RAMS requirements. So so what yes, so the process itself is same. Yes, it can be applied to other systems, so any systems from the design concept until the end. The process itself same. The difference is how we define the RAMS requirements and the risk acceptance criteria. So on. Yeah, so it should be applied in the system sector, like example. Yes, so for example, like this. So every risk or every category should be defined clearly. So for example, this frequency level here, more than once every 5,000 kilometers per train. So it should be clearly defined, the levels, the categories. And for any other models like FMECA, the process itself is the same. The columns which should be considered, like the failure mode, failure cause, failure effects. The process it's same for any systems. Maybe it's depends on the components. The failure modes can be same, it can be different. And in FTA process, it's yes same, because the process itself it's a quantitative or a model. So I think it should satisfy the questions. The other questions is
okay. Maybe before the question, I think there is one participant raising hand. So maybe I will let her to ask directly. So she's also a lecturer in ITS. So please, Bu Fadila, if you want to ask the question, you can. Oh yeah, you already.
Okay. Thank you very much for the time. And also thank you very much, Pak Alphonsus, for your very interesting explanation. I'm Fadila from the Department of Marine Engineering, and now actually I'm studying in Kyushu University, Japan. And here I would like to ask maybe 2 questions about the risk assessment. And as we know that you already have explained that risk is like more like multiplication between frequency and consequences. And my first question is, what if we, in my cases that maybe we cannot find the similar or maybe the relevant standard for using the risk matrix. I mean, like, what if our case is so we cannot find any risk matrix that relevant to our case? What should we do? Should we like define the frequency or consequences by ourselves, or yeah, how can we find the risk? And the second question is, can we rely only on one dimension? I mean, if we're gonna define the risk, can we only use the frequency or consequences? So just one dimension. Thank you.
I'm sorry. Can I? For the second question, your question is, can it only consider one dimension?
Yeah. So as you have explained that the risk is rely on both frequency and also consequences. But what if we only have one dimension? So we can't really define the consequence, for example. So we only have the frequency. So can we define our risk only from that dimension?
For the first question is, yeah, the risk matrix. Can we define the risk matrix ourselves? Yes, I mean, you can propose a new risk matrix. You can propose another risk matrix. This is just an example of the risk matrix. You can define, you can propose the frequency levels categories. You can propose the severity levels. But it should be clearly described. When find only two categories, what is the definitions, what explanations. Same for the frequency. But what I recommend is we should like refer to the previous studies, and also we can discuss with the manufacturers and the users, because I think they know more about the systems and how they will be operated, and the cost and the frequency of the frequency and the severity of the hazards. So yes, it's not a problem if we define the another risk matrix. And for the second questions, I want to say no. I want to say no. You cannot. You may not consider only one dimension, because risk is both frequency and severity. But when you define the severity is one column, then it will be like one dimension, right? So it should be also defined, should be explained why you only consider one severity level, like that. Because the concept itself is like both, yes, the multiplication of the frequency and severity. But if you like have a clear reason why you define a one-dimension matrix, then it can be applied. It depends on the case itself, actually.
Okay, thank you for your
explanation.
Okay, thank you, Bu Fadila and Dr. Alphonse. So now we go to the third question. This is from Bu Anda Iviana. If Bu Anda, if you want to ask directly, you can open your microphone. Otherwise, I will read the question. Okay, ya, ini pertanyaannya bahasa Indonesia. Jadi Pak Alfon bisa jawab pakai bahasa Inggris atau bahasa Indonesia senyamannya. So, pertanyaannya adalah apakah reliability prediction selalu menggunakan data TTF, TBF, time to failure, time between failure. Kondisi ini dapat dilakukan di hilir di mana data semakin lengkap dan ideal. Bagaimana bila kita berada di tahap early design untuk memprediksi keandalan produk atau sistem, di mana tahap tersebut seringkali dikondisikan dengan imprecise failure data. Silakan Pak Alfon.
Oke, reliability prediction. Karena pertanyaannya dalam bahasa Indonesia, saya jawab dengan bahasa Indonesia saja, biar penanya bisa mengerti. Ya, ini banyak masalah di data ya, di adanya data atau tidak, pertama di tahap early design. Umumnya kita pakai library, jadi ada data library sama seperti perpustakaan, jadi ada perpustakaan data. Jadi di software, salah satu software reliability, kita langsung cari nama komponen ya. Contohnya seperti ini. Jadi nama komponennya apa di sini? Part classification. Di sini nama perpustakaannya, nama library-nya. Jadi nama itemnya apa sesuai dari perpustakaan itu, library itu, dia keluar prediksi failure rate prediksinya. Jadi dari komponen failure rate, kita bisa prediksi sistem failure rate. Masalahnya, kalau kita pakai itu, bukan masalah, ya umumnya ini ada disadvantage, ada masalahnya di sini. Umumnya bedanya banyak dengan real system, jadi data dari perpustakaan itu, karena datanya mungkin belum diupdate atau sistemnya sudah lama, jadi ada banyak perubahan dari nilai failure rate itu. Jadi ada perbedaan yang cukup signifikan. Tapi metode ini umumnya dipakai untuk di early stage. Seperti itu. Jadi juga ada kalau ada info dari masing-masing komponennya. Jadi misal kapasitor dia jenisnya apa? Dia keramik atau elektrik atau semacamnya. Jadi dia failure rate-nya akan berbeda-beda. Jadi kalau ada info dari komponen dari BOM information, dari part list-nya, ya bisa dipakai di situ. Jadi tidak harus dari real data, tidak harus dari real time to failure or time between failure. Terima kasih.
Oke, itu jawaban dari pertanyaan yang ketiga. Selanjutnya mungkin ada lagi yang mau bertanya. Mungkin dari Bapak Ibu atau misalnya Pak Dedi atau Bu Wiba Kalau ada yang mau ditanyakan, silakan. So especially for me, this is maybe this is new knowledge for me, because actually I also learn reliability, but like this is like a multidisciplinary science. So where it not only we from statistics people, but also maybe like industrial engineering, but also like other engineering department. Like actually, most of the questions come from people with background in marine or maritime engineering. So it's about the ship operation. So please, if anyone has any question, you can ask. So maybe I will ask, for example, in like the reliability analysis. So in the railway system, I'm sure that the data is also large. I think because the railway system it operates like maybe almost 24 hours. So we and then yeah, maybe the data is collected real time. But my question is, since nowadays like we artificial intelligence or maybe like deep learning is quite hype. So does that also apply in RAMS in this RAMS analysis? In your case, how about?
Yes. Actually, there is one one subsystem in train. So it show whether the system is fails or not. So it's like an alarm, but it's different from the recent technology. Like it show like the failure level, the fault level, right? It's not like that. So it's about the continuous monitoring, yes, but not the prediction. But recently there are like a new sensor which will be applied in the railway electricity. So it fuel the railway infrastructure power. So we want to monitor the cable. Actually, the cable fails or not, and it should show the conditions, and we are proposing a model to determine when we should do the maintenance. So the problem, the difference with the systems in manufacturing is that the train usually cannot be stopped during operation, right? Yes. Because it's the service, the public service system. So when the component fails, we should not directly maintain. We cannot actually, except when it is very emergency. So in that case, the risk itself, like when what is the emergency level, should be defined in RAMS analysis. So that's the main point of RAMS analysis in the public transportation area. So about the maintenance and so on, it should be considered like in further development stage. So yeah, there are not many components with sensors. So because the components are so many components in the train, and it's really difficult, even though it's really difficult to monitor all components, like thousands of components. And even though we can monitor, it's difficult like to decide whether we should do maintenance or not. Yeah. I think so. So the director, so the director of the company in the memos is say, well, it's good to have a sensor which monitor continuously, but because of like the limitation in the train maintenance time and so on, it's still difficult to be applied in the railway area.
Okay, now we could continue to the following question. So, ini pertanyaan lanjutan dari Bu Anda Isyana. Reliability improvement seringkali diidentikan dengan bertambahnya biaya. Adakah peluang aktivitas ini dilakukan saat industri juga ingin mereduksi biaya manufaktur? So thank you sir, I'm sorry because I'm driving in the middle of that. So iya, jadi Bu Anda nggak bisa bertanya langsung karena lagi nyetir ya. Jadi silakan Pak Alfon dijawab pertanyaannya.
Reliability improvement ya, jadi umumnya memang kalau ingin meningkatkan reliability, kita ubah desainnya mungkin dengan lebih kualitas, lebih high quality material, dan umumnya lebih mahal. Jadi dengan penambahan atau perubahan desain itu umumnya memang menambah biaya. Jadi tergantung dari what kind of reliability improvement task. Jadi tergantung dari cara meningkatkan reliability itu. Jadi mau mengubah desain atau menambah maintenance procedure atau apa yang tidak meningkatkan biaya. Ya memang kalau ada action yang bisa mengurangi biaya lebih bagus. Cuma umumnya memang menambah atau merubah desain malah menambah biaya. Jadi tergantung dari action yang dilakukan untuk reliability improvement. Ya.
Oke. Ada lanjutan lagi ini dari Pak Krisandi yang pertanyaan pertama tadi. Sebenarnya pertanyaannya itu adalah apakah RAMS telah diterapkan pada setiap transportasi agen khususnya dalam perkeretaapian dan Ministry of Transportation di Korea? Karena saya melihat ada model sangat kompleks diantaranya stakeholder Kalau di Indonesia ada pihak PT KAI dan Dirjen Perkeretaapian, Policy Plan and Funding. Adakah bisa diterapkan yang lebih sederhana, dengan kata lain, salah satu indikator saja misalkan dipilih terkait safety saja? Maksudnya RAMS-nya lebih sederhana gitu ya mungkin.
Tidak ada, Pak. Jadi jujur ini tidak ada, karena safety sangat berkaitan, apalagi safety dari public transportation system. Jadi berhubungan sama mass, jadi massa, sama kehidupan banyak orang. Jadi safety di RAMS analysis, terutama di railway system perkeretaapian, harus diatur dengan pemerintah, dengan manufacturer, dengan operating companies. Dan ini ada di standarnya, jadi harus diikuti. Karena berhubungan dengan siapa yang bertanggung jawab jika ada accident kayak gitu. Terima kasih.
Oke, terima kasih Pak Alphonse. So, okay, so this is maybe the last chance. If anyone has any question, you can ask directly, you can speak directly, or you can write in the comment box. Okay, so we will wait for a while. Because it's already 11 a.m. now. If there is no question, so we could ada pertanyaan dari Bu Maya, raise hand. So please, Bu Maya, you can talk. You can turn on the mic and speak directly.
Thank you for the time. I want to ask something about the energy system integration and enabling technologies about RAMS. The example about the Aberdeen Hydrogen Bus project is the world-class demonstration of hydrogen fuel cell buses. The implementation of the
Maaf, suaranya hilang.
Sorry, Bu Maya, we cannot hear you. So, are you lost? Okay. Okay, hello, Bu Maya. Do you want to continue?
I'm sorry, sir. My internet is unstable. I asked in the chat room.
Okay, we will wait. Okay, so Bu Maya will write the question in the chat box. So is there anyone who wants to ask question? So the question is, I want to ask about ramps in energy in the challenge, like as how to implement it on the scale needed to achieve the SDGs target or something, and when it's of visualize big data in transportation energy ramps, what are effective to reach SDGs? So maybe Dr. Alphon, you can read the question and answer it.
Can you define what is the SDG?
SDGs is Sustainable Development Goals, if I'm not mistaken. Yeah.
Implemented. I think it's in the more to the requirements of the RAM, like the reliability, availability, and maintainability instead of the safety. And the sustainability itself, and it's I can't find the correct answer, I think, but in my opinion, it depends on the requirements itself. Like so far, I didn't find like in my 2 years work experience in Emosis, because I didn't face this sustainability target itself. It's more like the common RAM target, like the reliability, like availability, like the how many hours it should works, how many hours it should maintain, so on. And so related to SDG, maybe it should be evaluated based on the cost, the cost, like the life cycle cost. So how we may obtain the most effective ways depends on the case itself. And in the trained railway sectors, it can be defined in, it can be optimized in the maintenance interval and so on. But also it should satisfy the requirement, so the RAM's requirement. So yeah, so it's not really specific to the SDG target, but maybe it can be considered like a similar way. Thank you.
Okay, thank you for the answers, Dr. Alphon. So I think there is no question anymore. So now we could actually end this session. So before we close this seminar, I think maybe Dr. Alphon, you have maybe have some closing statement. So please.
Yes, okay. So I just would like to say thank you for the opportunity and thank you for listening to my boring explanation, very long presentation. But I hope my presentation can be help for your study, for your works in any area. So, and if you have any questions, still ask. You can find an email or contacts.
Okay. Thank you for the closing statement. Now we. So now I think it is time for us to end this seminar. So thank you very much for Dr. Alphon for the great talk. So I'm sure it's must be very useful for everyone. Maybe if the participants, like Dr. Alphon said, if you are interested in this topic, you can contact him in outside this session. So maybe you can also find him on his LinkedIn or anything. Yeah. So yeah, once again, thank you for Dr. Alphon, and also thank you for all participants for this 2-hour seminar. We really appreciate your attendance and also your participation. And then don't forget to fill out the attendance list to claim the certificate. And also we would like to apologize for our mistakes. Hopefully it can be better in the future. So yeah, so I think that's all for this seminar. Thank you for your attention. Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Yeah, thank you, everybody. The material can be reviewed again via our YouTube channel for the participant. Thank you all. Thank you, Alphonsus.
Thank you,
everybody.
Alphon, Mas Novi.
Thank you.
Can I
Yes.
end meeting for all? Okay.
Yeah. Okay. Thank you.
Thank you.
Good afternoon, everybody.